All right. So this is, in my opinion, sort of the crowning jewel of what we want to do with Taylor series, okay? To me. So let's start with just some binomial expansions. I know, it's like, what the hell? Binomial expansions. So we have 1 plus x, that's an easy one. Okay. 1 plus x, if we square it, that's 1 plus 2x plus x squared. Okay. 1 plus x cubed, that's going to be 1 plus 3x plus 3x squared plus x cubed. You may remember this Pascal's triangle. Okay, but this is sort of where it comes together. Let's do one more. 1 plus x to the 4th equals 1 plus, well, there's 4, 6, 4, 1. 4x plus 4x squared, oh, sorry, plus 6x squared plus 4x plus 1. Okay, now let's go ahead, let's imagine that we have 1 plus x to the n. It's going to be 1 plus x multiplied out n times. Okay, so now we actually have some nice formulas for the coefficients. Okay, I mean, this is how you generate them if you're doing them by hand and don't have a calculator, but you can also do this sort of choosing thing. N choose k. It comes out to be this crazy n factorial over k factorial, n minus k factorial. Not so crazy a formula, actually, but, you know, takes some getting used to. And it's how many ways to choose k items from a set of n items. Okay, so this has some links with probability. So what you're sort of thinking about is, let me move this here. Okay, so this 2 represents how many ways can you really multiply x, just one x here. Okay, the 1 here is how many ways can you multiply 2 x's there. Maybe it'll make more sense with you do a higher term. This 3 represents how many ways can you just multiply 1x. So it's like you can do this x times 1 times 1. That's one of them. This x times 1 times 1. That's 2 of them. This x times 1 times 1. That's 3 of them. Okay? This is how many ways can you do x squared. It's symmetric because, you know, if you're doing x squared here, that means you just have 1, 1. So this could be 1, this x is x. This could be 1, this is x, this is x. Or this could be 1, this is x, this is x. That's the 3. So that's what this is representing. Let's do one more just to really beat it into submission. Okay, so this 6 represents how many different ways can you multiply to get x squared here. So that is 4, choose 2. Okay, So you've got x squared here, that's 1. You've got this x with this x here, that's 2. This x with this x here, that's 3. Okay? Now, let's say you now say, okay, I've used up all the ways to use this x. Okay? So now, what about this x? Well, I've already used up that x. So I've got this x times this x, or this x times this x. That's 3 times 2. That's the 3 times 2 factorial. If I use this x, there's just one way. These two are already burned. Okay, so that's sort of a first step. You don't really need to know that, but I just wanted you to see this does not come from nowhere. Okay? These are all connected, and you actually get a little bit of probability theory here. But where's the Taylor series? Okay, where's the Taylor series? Well, what we have here is that if f of x equals 1 plus x to the n, this equals the sum, k goes from 0 to n choose k. All right. Why did I do that? This was wrong. That should have had x to the third, x to the fourth there. N choose k, x to the n. Or, sorry, x to the k. All right, so what does that tell us? These are the Taylor series coefficients, okay? So the kth derivative at 0 equals, remember this is 1 over n factorial of the derivative. So this is n factorial, I'm sorry, k factorial. This is 1 over k factorial of the derivative of n choose k. All right, so it all sort of comes together. N factorial over n minus k factorial. Okay. So far, no big deal. Nothing special. But what's awesome is we can now go outside of integers. So what we're going to do is we're going to say, okay, well, what about something like 1 plus x to the r, where r is no longer an integer? Okay, well, we're going to write this as the sum, k goes from 0 to infinity. We're going to write this as r choose k. All right, we don't really know r choose k yet. Let's suspend disbelief for a second. Okay, x to the k. Now, we do know a few. R choose 0, we're going to go ahead and define that to be 1. Okay, R choose 1, we're going to define that similar to how we defined n choose k. All right, so that's going to be, let's do it for n choose 1 first. Well, no, let's do it. Sorry, R choose 1. Let me write that a little bigger, though. That's going to be r factorial, which does not have a meaning yet. Okay. 1 factorial, r minus 1 factorial. Okay. Still, none of that really has a meaning, but n choose 1, n factorial, 1 factorial, n minus 1 factorial, that's actually just going to equal n. So we're going to give this an equality of r. Okay, so r choose 1 is r. Let's do n choose 2 and then r choose 2. n choose 2 is n factorial, 2 factorial, n minus 2 factorial. So that's going to be 1/2 n times n minus 1. So we give r choose 2 the value 1/2 r times r minus 1. Okay, let's do, actually that should have been n choose, nope, that was right. Okay, all right, so let me come back and I will do an example with this. Okay, so I'm running out of space.